Alrighty, I think we're live. I'm gonna give it a couple of minutes and allow other people to show up. Cool. Yeah, and just check on my phone and make sure that we're actually live. Awesome, so it looks like we're live. So hi everybody, welcome and happy Easter. So today I thought I'd solve a bunch of easy questions on LeetCode, easy coding interview questions. So if that sounds like something you are interested in, just stick around for the next hour or so. Alright, quick disclaimer is that I may have seen some of these questions before. Actually, I have. They're already displayed on here, and these are questions that I may have solved on maybe like Cracking the Coding Interview or some other platform. So I may not be completely new to all these questions, and because of the way LeetCode asks the questions, some questions may be related to other questions, so I'm not completely novice to all of these questions. Although this is the first time that I'm solving them on LeetCode. How did I pick those questions? So I have been solving a few questions on LeetCode here and there, but one list that I try to stay on top of is the top interview questions list. That's this list right here. So I always try to stay on top of these questions in this list, just because it's a curated list of all the top interview questions, and it would be good to solve them. So if I display like the questions that I may have solved on this part, how do I do that? Status solved. Yeah, you can see that I've solved a bunch of them. If I go to difficulty, medium, I've solved a bunch of these. Like, this is my primary list of questions that I solve on LeetCode. But lately, I have realized that I am slacking behind. And there are a few questions, easy questions that I haven't solved. And I was like, what better way to, catch up with this list than just make a live video and see an actual feed of how someone would be solving LeetCode questions. Okay, so that's it. I have no idea what to do next and just what order we're going to solve it in. I think I'm just going to solve it as it is. I might mute my microphone, I might turn it on, turn it off, depending on how things go. Also put some comments in the chat, like if you're getting some feedback. The last time I did like a live video, I had some feedback, so if you're getting feedback, put it in the chat so I would know, and I would mute my microphone. Alright, awesome. So thanks for joining, guys. We're going to solve the first question, and that is happy number. My internet. Every time I stream, it's like this all the time I stream. Let me just try typing something. Alright, it's not as slow as I thought it would be, but if it gets really slow, I'll just pull up something like a notepad. I think Chrome gets really slow when I stream, so yeah. Alright, so happy number. Write an algorithm to determine if a number is a happy number. I'm guessing there are some criteria about which number is a happy number. So starting with a positive integer, replace the integer with sum of squares of its digits. Repeat the process until the number equals 1, or it loops endlessly in a cycle which does not equal 1. Okay, so this is a pretty straightforward question. You should determine whether a number is a happy number based on these things. So we're going to implement these things. The very first thing that comes to mind is to do a simulation of this number, and every time we get a number, like while number is not equal to 1, do this and do that. But that is going to be not as optimal as I would think, because if we say, for instance, we have a couple numbers, I think we have 80, and then we do while 80 is not equal to 1, just type 90. While 80 is not equal to 1, we do stuff. Like, we're going to keep doing stuff until 80 is 1. So this would be an infinite loop. So we need to have a way to check whether we're in an infinite loop and then break out of that loop. So I'm not sure how to do it right now. Let's see if we can discover patterns in this question. So yeah, I'm going to mute my microphone and let's code. What stuff are we doing? Here we have to get the digits in a number. So if it's a 3-digit number, it's a 2-digit number, we have to get the digits in a number. And when we get the digits in a number, then we multiply their. We add the sum. We sum the squares of the digits. So let's write a function to get sum of squares of digits. So public int get sum squares. And then we're going to loop through n, get the last digit, get the square of that, add it to a number, and then so in answer, first of all, let's make the sum number be 0, and then we could start looping through. So if we have something like 19, and then we want to get 9. So if we do 19 divided by 10, our integer division should give us 19 divided by 10. Yeah, integer division should give us the last digit, and then we keep doing it until we get it. So now n is not equal to, I guess if it's 1, how would we do it? We just keep getting the last digits. So we can say while n is greater than 10, right? And then if we do calculator equal let's use like a really ridiculous number. Just try a couple of these. Oh, sorry. Alright. I think we're done with this. Now let's get going. So if n is ever less than 10, we just get whatever the square is of the last digit. Digit would be 10/10, I'm guessing. And then, so if we get the last digit to be n/10, and then we can just add equal to last digit times last digit. So this should give us the sum, and after getting the sum, we could add the sum to sum. I'm quickly going to run through some print statements just to make sure that we're actually getting the last digit. So I just realized that this should be modulo instead of dividing it by 10. I just realized that if we do 19 divided by 10, we're going to get 1, and that means that we're getting this right here. That's the remainder, and not actually the last number. So what we want is modulo 10 for the last digit, and then, so that should be n modulo 10, and then for the remainder, should be divided by 10. So that should give us, I think I'm going to leave this open. That should give us 19 divided by 10. It goes into it once, and that should give us this guy right here. Awesome. So then we can set and to remainder. So n is equal to remainder. Well, hopefully, when we're done here, we can just get the one digit, and that will do it. Let's print some print statements and see what happens. So in this case we got 1, we got 9. I'm just trying to find a better way to do this since we're dividing by 10. What if we have something like 9? What if we pass something like get num squared is 9, and then output false, your output 19, less than 10, and then we can just do 9 because it's one digit. Makes sense. How about 90? Is 9. 91. Remainder is 9. Okay, 9. Remainder should be nothing. Is greater than 0. Infinite loop. Yeah, I'm just trying to get rid of doing something outside of the loop. I just want to do everything in the loop. Yeah, it's insane. Okay, so remainder should be 0, and then last digit. Let's print out the last digit. Like, I don't really care about the remainder at this point. All right, cool. So now we don't have to do stuff outside of the loop, because I thought if we have only one digit in the number, then we can, process it here. But now we don't have to, so that's good. Alright, so this should be pretty much okay. Let me do something like 91 and see what we get. There's the sum, and then 82. Let's try 19. See what we got. Alright, so the first one we got 82, which is awesome. That is exactly what we're looking for. Then we have to keep, looping through 82. So, what we can do is that while num is not equal to 1, do stuff, and that stuff would be getting the sum. And after getting the sum, yeah, I guess I can just print the sum, and then set the sum to num, and then return false right here. And then we can just set the sum to not. No, we got some. Let's see what happens. Let's keep doing this. Hmm. 82. Oh. Yeah, I see what's happening. Very cool. Alright, sum is 1. So at the end of this, guys, sum should be equal to 1. So return sum equals to 1. Num. Alright. So yeah, it worked for 19. We gotta make sure that it works for other things as well. That means that let's look at patterns. Let's see if we can discover patterns. How do we know we have patterns? Run this again. Keep getting a lot of notifications. What the hell? Alright, 82, 68, 101. Now let's try something like 2. 4, none. Let's see what we get. Let's see what we get. So 4, 16, 58, 89, 14, 42, 24, 16. Oh shoot. And then when we get 16, we're basically going to repeat the same thing over again. 16, 37, 58, yes. So we have a loop at 16. Alright. So we got to make sure that we don't have loops. Because if we ever see a number that repeats itself, and then we go into the while num is not equal to 1, we're going to get the same sum every single time, and we're never ever going to get to 1. So what we can do is we can have something like a map. I don't think a map would be the better way to do it. Maybe like a set, because the way set works is by default it only holds unique values. So if we ever get something that we've seen before, maps can hold duplicate values. Do they? No, actually they don't. They update themselves. So if you add something like, say, map.put1, and then you do it again, it updates that 1. But sets only hold unique values. So we can have something like a set, let's call it set of integer, set is equal to new hash set. And then every sum we get, we add that sum to the set. So just do set that, get sum, and then we can say, first of all, let's check if set that contains get sum. We've seen it before. We just return false. If it's not there, we add it for the next iteration, and then we set num to get sum. Now let's run this, see what happens. Interesting. We try 19 or 2. 4, 16, think this should do it. Let's try running it one more time. Instead of setting num to 2, let's set num to n. Run it again. Okay. Submit. It's not gonna work. Oh yeah. Awesome, it worked. Alright. I do like to submit things a lot of times just to raise my submission percentage. I know it's a little fishy, but yeah. If you go to my account, right? Let's go there real quick. The percentage of my acceptance rate, it's like 62%. In reality, I think this would be maybe 50%, I guess, because I keep resubmitting stuff. Okay, so that's it for... Is my microphone on? I'll just check the chat and make sure there's like nothing going on. Alright, so that's it for this question. It wasn't a really hard question. The only things were determining how to get the last digit, how to get the remainder, and how to like navigate the whole things. And mainly, the part of this question wanted to test your ability to determine patterns in questions. And when you find patterns, how do you navigate that situation and all of that. So questions like these, you'll definitely not get in an interview. Maybe like a phone screen, but not like a technical on-site interview, maybe a phone screen. But yeah, it was a cool question. Let's solve another one. Next question is Pascal's triangle. So you know what Pascal's triangle is? It's a math triangle with patterns on there, like ones, and then you add the 1, and then you get 2, and then you add 1 and 2, you get 3. Like this dude on YouTube, what's his name? Veritasium. He had a very cool video about Pascal's triangle. And how Isaac Newton created a new way to check for pi using Pascal's triangle. I think this is the video. And I think it's great. So if you want to learn more about Pascal's triangle, go check it out. This video said something about using negative numbers in Pascal's triangle. I hope it doesn't say in this question, because using negative numbers is insanely difficult to do. Well, yes, it freaking is. Like using radicals, negative numbers, and then exponents, it's not something that I would want to do. Hopefully, they're non-negative. So given an integer number, return the first numbers of Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it, as shown. Okay. So we have numerals equals 5, and then we should return 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, like this, 1, 4, 6, 4, 1. Okay, so when I look at these types of questions, the very first thing that comes to my mind is running a simulation. The way programming languages are right now, you can run a simulation for almost anything, and every time I get the thought about running a simulation, I always think that there's a better way to do it. There was this question on Google Kickstart about ATMQ, and I ran a simulation. I think there's a video on this channel. And then it did work for a few test cases, but then I got time limit exceeded. Like I knew the simulation would work, but then you don't want to keep looping through stuff. So when I get these types of questions, my main focus is trying not to do a simulation and maybe see there's a way to maybe use modular operators, maybe bit manipulation, to just get rid of the simulation idea. Also, another trick is to take a close look at the requirements for the number of rows that you're going to be given. So for now, we're going to be given at most 30 rows, which isn't that bad. If you're given something like, say, 10,000, 100,000, then that's really bad, because you don't want to run a loop for 100,000, right? But for something like 30, it's totally fine to run 30 instances. It's going to run an O of n for the first loop. O of n times something, that would be O of n times the longest number of rows, the row with the longest length, which would by default be the last row. So O of n times num rows, blah blah blah. And yeah, so it would be O of 30 times 30, maybe O of n squared. Which isn't bad. Isn't bad at all. So let's run a loop of... I haven't talked about how I'm going to solve the question yet. So what we can do is add 1 to the first level, and then on the second level we keep adding until the number of rows is greater than num rows, basically. So in rows so far, rows now, let's set it to 0, or maybe we can just set it to 1. 1, 2, 3, 4, 5. And then we can say, well, rows now is less than or equal to num rows. We keep doing this until we get, number of rows and stuff. I think we don't even have to start from 1. We can start from 0. And then we set it to less, so that would be 0, 1, 2, 3, 4. That's still fine. And then let's make a list of list of integer. Let's call it answer the array list. And this array list is going to be where we add the rows in. So this would be rows, and this would be a list of rows. So let's determine how we're going to add the rows. That really depends on the length of the rows. So as you can see, the first row has a length of 1, second has a length of 2, third has a length of 3, fourth has a length of 4, fifth has a length of 5, like that. So rows now plus 1, because we're going to start from 0, should be the length of this row. So len of row should be rows now plus 1. Alright. So the first number is always going to be 1. So we can just create a new list of integer and call this row, and we go to the array list. And then in this row, we're going to add 1 as the first one. So let's say this row that I add 1, and then we loop from from 1 to rows now to len of rows minus 1, because the last one's also going to be 1. So I, where I is equal to 1, I is less than len of rows minus 1, and then I is plus. Interesting. Alright, so we gotta figure out a way to get the previous row. Cool. I'm just thinking, if we're in the first row, like, we don't have a previous row, so there's no previous row, so there should be a check for that as well. And then at the end, we can just add this word to add 1. That's for the last number in this row. And then from now to the second to last number, and then we just keep adding the sum of stuff from the previous row. So So now let's make sure that we do have a previous row. So if rows now is greater than 1. Interesting. Greater than 0. And the first one's going to be 0. If rows now is greater than 0, then we can do this. If it's not greater than 0, then we don't have to. We can just add the first number. Like this one is in its rightful position. Are we good? And this one should come here. Okay. And how do we get the previous one? It would be rows now minus 1. Alright, so from here, what we can do is get previous so where's there? I don't even think we need to get previous row number. Like we don't have to keep creating many space variables that hold a lot of space. You can just say int prevnum would be equal to rows now minus 1. And then for n I is equal to 1, the 2 rows above that would be this would be 1 and 1 1. This would be 1 2. 2 rows above it would be the first one and the second one. So this row would add rows answer that get prev num enter to get prev num that get first one would be I'm trying to see would be 0 I minus 1 and then the second one would be 1 so I minus 1 and I plus answer that get num and get I. Interesting. I think this should do it actually. Let's run a few test cases and see what happens. Let's integer answer, line 4. Oh. Please work. Time limit exceeded. We're not updating rows now. The rows now should be plus plus. Yeah, I knew it would have problems here. Okay. At line 64. So let's try to print out what rows now we're looking at. let's debug this. Suppose now is 2, and then we're trying to add answer that get prevnum, which prevnum is 2 minus 1, should be 1, and then we could get this. And that's 1 out of n, x will length 0. So check from 0, if it was not greater than 0. So we did not print 1, which is that. Try something different. Alright, 0, 1. So we got 1, but then we did not go in here. Why did we not freaking go in here? Because we are not adding it to answer. Yes. Gotcha. We should add this row to answer when we're done with it. So we can just say answer to this row. Cool. Yes, 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 yes. So I have no idea whether I'm a little nervous because I'm doing this online, and then I would want this video to live on the. I wouldn't want to set it to unlisted. I would want this video to be public after the stream. So yeah, live shit, man, live shit. This again. Full submit. Awesome, works. And to the next question, that would be counting primes. Have we been streaming for about an hour? I am not sure. Yeah, but I'm gonna cap the stream at about an hour. Maybe 3-4 questions, that should do it. Count primes, yay! I have seen this question a bunch of times. This should be an easy one. Well, depending on the number of loops we're gonna make. Constraints, yo! It is large. It is really, really large. Oh my god. So count the number of primes. On phase value, what you can do, there's like an n-squared solution where for every number you count the number of primes in that number, add it to the sum, and then you return the sum. Which, yeah, let's try that. Let's try that. So public boolean is the prime number is a number that is divisible by 1 in itself, by only 1 in itself. That means that you would have to look through all the numbers less than that prime, and then make sure that it's only divisible by 1 and itself. X. 2 is the first prime, 3 is another prime, 4 is another prime, 5 is a prime whose 1 and 5. So I guess we don't have to check for 1. We already know that, you know, it's divisible by 1 with every number. And then we'll only have to check for whether 5, the last number, is more than the number that's not divisible by. Okay. So that means that we can say is equal to 1 2. Y is less than n. Y plus plus. And then we can just see if n modulus I is equal to 0. Return false. And then here we'll just return true. Yeah, let's try a few examples. So let's print out is prime 1. Should be false. Yuck. True. One's not a prime. Well, that's debatable. Don't quote me on that. So, let's say if is equal to 1. At least for here, that they think, yeah, one's not a prime. Start from 2. Y is equal to 2, Y is less than n. We're not going to run this. So if I is greater, Y is less than 2, that's less than 3. But then we don't want to return true for 1. N is equal to 9. That is less than 3. So from 2, let's just say 2. Okay, false. Nice. And then let's check 5. 5 should be prime. True. Yeah, 5 should be prime. Now let's check for 2. 2 should be prime. Okay. Alright. So now that we have a function that checks for whether or not a number is prime, what we can do is we can loop through int I is equal to 0. Yikes. And then we don't want to return true for 0. Just want to start from 1. Y is less than n. Less than equal to n. And then for every number, count the number of primes less than a non-negative integer. So we have 10. We have 4 primes less than 10. There are 2, 3, 5. Okay. So we can just say if is prime I, and then we can do count plus plus. If we don't have a count should be 0. And then count plus plus, and then we just return count. Cool. Yeah, this is gonna be hard. At least I is less than math is squared. Let's try to math that SQ or XQ. Math is squared. Alright, that'll work. Yeah, I vaguely remember that there are some crazily ingenious solutions to this. I know if I submit it, I'm gonna get time limit exceeded. Let's see. Oh wait, input 2, output 1, expected 0. Why? Oh, less than the non-negative. Okay. Let's try to... let's submit this. Yeah. It's insane. It's insane. Alright, let's see what we can do. See, there's a quick fix on whether or not to loop all the way through n. This is an O of n squared solution, by the way. Many months ago, when I was reading this book called Cracking the Coding Interview, there's something called the sieve of Eratosthenes. Am I pronouncing that right? So that should do this. So it basically works on the principle that every prime is divisible by another prime. So you could, potentially get the next prime if you know the previous prime based on the divisibility rules. Now, I cannot think of how to implement that. Like, I have a basic idea. If I could write down the solution to that, it would be rough, but I'd try to maybe have like a Boolean. I'm just saying this exactly as how they did it in Cracking the Coding Interview. You have a Boolean array of the primes that you think is true or false, and then you can have another function that cancels those ones out. So if something's prime, then you make it true. If something's not prime, then you make it false, and then you get the next prime based on the divisibility rules from the sieve of Eratosthenes. So now let's search for the sieve of, yeah, there it is, Eratosthenes. How does it work? So in mathematics, the sieve of Eratosthenes is an ancient algorithm for finding all prime numbers up to a given limit. It does so by iteratively working as composite. Starting with first prime number, multiples of a given prime, blah blah blah, equal to that. This is the sieve's key distinction from using trivial division to essentially test each candidate's number divisibility by each prime. The multiples of a given prime are generated as a sequence of numbers starting from that prime. So you have to generate multiples. Okay, so that's easier to do. So instead of doing like dividing by, so if you're checking whether I is divisible by n, instead of doing I plus 1, I plus 2, just do I times I, but like that. This seems pretty cool. I like this animation. So yeah, I'm not sure I'm going to solve it. How long have we been streaming for? Let me check the stream health. We have been streaming for about an hour. I think I'm going to end the stream now. Thank you so much for joining in, guys. We solved 2.5 questions in about an hour. I'm going to say 3, right? Let's call it 3. 3 questions in an hour. Count primes, did pass a few test cases. I'm going to solve the sieve of Eratosthenes. Comment down below if you want me to make a video about the sieve of Eratosthenes, and I will make a video about it because it's pretty cool. Okay, so that will do for me. I hope you had a wonderful time. I hope you have a great Easter, and I also hope that you pass all your coding interviews, I guess. Good luck to everyone prepping up for coding interviews. Good luck to everyone prepping up for competitive programming rounds, whatever it is. Good luck to you guys. Thank you for doing algorithms and chilling with me. Algos and Chill. This is the second episode of Algos and Chill.